In this question, there is a system which is released at rest. It consists of 3 charges of charge Q kept at the 3 vertices of an equilateral triangle of side A. These are not connected to each other. This is just on the corners of an equilateral triangle of side A. Now, what happens is that due to the forces acting on each of them due to the other two, these start moving outwards. And when they reach the vertices of an equilateral triangle of side 2A, at that point of time we need to find out the speed of each of the charged particles. Now in this question, by symmetry, each of these charged particles will be always moving along a equilateral triangle. So there will be a point of time when all these 3 charges come to the corners of an equilateral triangle of side 2A. At this point, each one would be having a velocity v. Since there is no biasness, it would be the same for all 3 of them. That will be equal to v. We need to find out this v. So in this question, the first thing that should strike you in this type of questions is that this can be solved very easily using the energy concept. So let us write the work energy theorem. What are the forces acting over here? The electrostatic forces on the system, the work done by electrostatic forces plus there is no other force, therefore this is equal to change in kinetic energy. Now electrostatic force is a conservative force. We always know that work done by conservative force, negative of change in potential energy, which is defined with respect to that conservative force. Always remember this, du is equal to minus dw. So work done by conservative force is negative of change in potential energy. Therefore this can be written as minus of delta u is equal to delta k. This is equal to u initial minus u final minus u initial, and with a negative sign becomes u initial minus u final. This is equal to change in kinetic energy. Initially the system was at rest. So this is equal to final kinetic energy, that is equal to half mv square. The masses of each of them are m into 3. Now the task we have in hand is to find out the initial potential energy and the final potential energy of the system. Now for a 2-point charge system, we know the potential energy to be equal to k q1 q2 upon r. Whenever there are more than 2-point charges, then the way to find out the potential energy of the system is, suppose we have a system of 4-point charges, then to find out the potential energy of the whole system, the thing you can do is that take all possible pairs. For 4 of them there will be 4 C2 pairs, and write down the individual potential energy of each of the pairs and then add them all to get the final potential energy. So the potential energy of this system will be, let this be R1, R2, R3, R4, R5. Let us do it for a 3 charge system. I will explain it here only. For this system it will be, for this and this pair it will be kq square upon A. For this and this pair it will be kq square upon A again. For this and this pair it will be kq square upon A. So the total potential energy of this system will be at this point of time will be equal to this plus this plus this is equal to 3 kq square upon A. Also, when we write down the final potential energy, A will be replaced by 2A because it will be kq square upon 2A into 3 times because of the 3 pairs. So this is the final potential energy. Let us subtract these two, so we get 3 kq square upon 2A is equal to half 3 by 2 mv square. From this equation, putting in the values we get over here, we cancel 3 by 2 to get kq square upon A is equal to mv square. Therefore we get the value of v is equal to q root over k upon ma. So our final answer, that is the velocity of the each of the charges when they reach on the vertices of an equilateral triangle of side 2A, comes out to be equal to q times root over k upon ma, and this is our final answer. So the thing you should have learned from this question is to how to write down the potential energy of a system of more than 2 charges. Take each of the pairs, write down the potential energy and add them up for each of the pairs to get the final answer as v is equal to q times root over k upon ma.